Hi guys and girls, a video here on the cosine rule. The first thing you will need to be able to do is label up a triangle. So if we have a triangle with corners ABC, then the opposite sides are little a, little b, little c. And these capital A's, B's and C's can move around. As long as the opposite side goes with it, it does not matter. You'll see on some other websites, if they start doing things on the cosine rule, they start moving letters around within the formula. That is just so confusing for a lot of people. It's far easier just to move your corners around to where you want them to be to make the formula work. The formula is, and it's one you're supposed to remember, that a squared equals b squared plus c squared minus 2bc cos capital A. So as long as you make capital A, the angle you're trying to find, this formula will work. So let's see it in action. Okay, so we have xy is 7.8. and it's isosceles, so this is also 7.8, and the angle YZX, so this one here, is 36. Again, it's isosceles, so this is 36, and we can work out that 2 36 is a 72, so this is going to be 108. These are all in degrees. Okay, what are we working out? We are working out the length of YZ, so we are finding the length of this line here. Now, we know all of the angles, so A can go wherever we want it to go. If you're finding a side, I would probably advise that you make this one little a, just because it only appears once in the formula. Otherwise you've got issues with having multiple B's and C's. So if this side has to be little a, this X is actually a capital A. And the B's and C's can go wherever you like. So that means that little c is this 7.8 and little b is this 7.8. So now we're going to sub into the formula. So again, I'm just going to quickly pop the formula up here. Okay, so little a we don't know. B is 7.8 squared. 7.8 squared. 2 times 7.8 times 7.8 times cos, and capital A is 108. So we go to our trusty calculator, type all of that right hand side in, and we get 159.28 ... So A is going to be the square root of that. Don't round it before you square root it. Only round at the very last stage. Oh, and I didn't say before, do make sure that your calculator is in degrees, not in radians or anything weird like that. So the question here asks me for 1 decimal place, so this is going to be 12.6 centimetres. Okie dokie. On to this one, perimeter. So we are looking to find this one here. So I'm going to make that one little a, which means this is capital A. Now I need to find, I'm going to put B here, so this is little b, and C here, so this is capital C. Okay, subbing into the formula. So a squared is b squared, which is 8.8, plus c squared minus 2 times b times C times cos capital A is 37. So again, pop that in your calculator, and we've got 30.697 ... Again, A is going to be the square root of that. Do not round it. Only round it after you've square rooted it. And we get 5.5 to 1 decimal place. And this is in metres. Again, 1 decimal place in the question. Does that sound reasonable? Yeah, your longest side is 8.8. The sum of the two smaller sides should be more than 8.8, otherwise your triangle can't exist. We've definitely got that, so it does seem like a reasonable solution. Okay, the next ones I've got for you are, I think, finding the angle. Oh no, sorry, I've got one length left. Right, so we're going to need a sketch here. So it doesn't matter what it looks like, in all fairness. Start putting the X, Y's and Z's wherever you like. Okay, so we know XY is 21.9 centimetres. We know XZ is 13.6 centimetres. And we know the angle YXZ, so that's this one here, is 26.3 degrees. And we are asked to find this side. So again, that one's going to be A, and you go through the process again. Change your X to an A, put the B there, put the C there. It will actually work either way round, and sub into the formula. I'm not going to do that one, that's just showing how to build up a sketch. It works the same way as the previous two. Okie dokie. These are the ones finding the angles. So again, I'm going to start with a sketch. It doesn't matter what it looks like. I'm going to start with X, Y, Z. In every which corner. We know XY is 12.4, and this is in metres. We know XZ is 10.4 metres, and we know YZ is 6.4 metres. Find this angle here. So I want that angle. I'm going to call that capital A, which means that this is little a. Just for something different, I'm going to go do it the other way around today, or now. So that means this is little b, and this is little c. Subbing into the formula, we get 6.4 squared is equal to 12.4 squared plus 10.4 squared minus 2 times 12.4 times 10.4 over cos A. Now we can't just shove all that in a calculator like we have done before because we don't know what cos A is. We can certainly work out what the left hand side is. We can work out 6.4 squared, so that's 40.96. We can certainly work out this bit, so 12.4 squared plus 10.4 squared gives us 261.92. And we can work out what this bit is, so minus, so 2 lots of 12.4 times 10.4 is 257.92. That is multiplied by cos A. Now it's a case of rearranging. So I'm going to, I want to leave the cos A there and move everything else. One big mistake people will make is they will work out that and think it's multiplied by cos A. It is not. Okay, this first part here is not multiplied by cos A. So the first thing to do is to take this away. So we get 40.96 take away 261.92 gives us negative 220.96. That is equal to negative 257.92 cos A. Now I leave that cos A there, I need to get rid of this bit. So I'm going to divide by it because it's been multiplied. 220.96 over 257.92. That tells me what cos A is. So what do we get? We get 220.96 over 257.92. We get 0.856 ... Again, I'm not going to round it because I'll end up with a rounding error. A is going to be cos to the minus 1 of this number that we've just found. So cos to the minus 1 of the number we've just found. Oops, I've pressed the wrong button on my calculator. Cos to the minus 1 is 31.1 degrees. Now, there's no reason why you can't rearrange the formula before you put the numbers in if you prefer, if you think it looks a bit tidier. If you're going to do that, this is what it would look like. Oh, that should be minus 2bc cos A. So if you're going to do that, take the b squared away, take the c squared away, so that will leave you with 2bc cos A. Now divide by minus 2bc. You can fiddle around with it a bit more, but the very last thing you could do if you wanted to is cos to the minus 1 of, and then what we've got there. If you prefer either to memorise this or fiddle around with it as a formula before you put the numbers in, fine. Personally, that's the way I prefer. I prefer rearrange the formula, then sub the numbers in. It's just a lot tidier, a lot easier. But I've shown it both ways. You can do it whichever way you want. That should be a C down there. There we go. Okie dokie. I think I've got one more. Yes. So find the smallest angle in the triangle with lengths. Okay, so we've got a 10. Oh, my longest side's a 12 actually. 12, a 10 and a 6. And we want to find the smallest angle. Well, we don't know necessarily which one the smallest angle is. I'm going to guess is that one. That's going to be 6. No, I think it's going to be that one. Anyway, we're going to have to find them all. So A, unless we did a slightly better diagram, bear with me. Sorry, just paused it there whilst I was having a think. If we were to scale this down a bit, so we had 10, because this one is shorter, that's going to make a wider angle there. This one is the shortest angle, so that's the one with shortest angle. Smallest angle, that's the one we're finding. So that's going to be my capital A. I'm going to put B. I always go round clockwise ABC. It's just my habit. It's kind of what you'll, well no, it is what you'll see in textbooks and things like that. It doesn't actually matter. Okie dokie. So we're going to do another finding an angle. I'm going to show you using the formula that I just rearranged for you to show you how much easier it is this way. Okay, so that was the rearrangement. All I've got to do now is plug my numbers in, which will give me that. And then I'll pop it into a calculator, which will give me A is 29.9 degrees. We could repeat the process to find this side if we needed to, just to prove it's the smallest. Bye!